Take a second to read this problem. A particle moves along the curve y equals negative 2x cubed plus 8 such that the x-coordinate is decreasing at a constant rate of 1/2 units per second. What is the magnitude in units per second of the particle's velocity vector? You might remember this as just speed, but if we think about the velocity vector, we're going to have an x component and a y component. And the magnitude is that distance of that hypotenuse. So we really want speed, or we could just find the x and y components and use the Pythagorean theorem on them. Well, fortunately, they give us that the x-coordinate is decreasing at a constant rate of 1/2 units per second. So as I think about this dx dt, it's really negative 1/2. But I don't have much guidance about that y component. But they gave me y equals negative 2x cubed plus 8. So I bet I need that. And also, we know that dy dx equals dy dt over dx dt. I was given this dx dt as negative 1/2. I'm looking for this. I need it in my triangle over here. That's that height I need. And I can find this just by taking the derivative of what's here. Dy dx would equal negative 6x squared plus 0. So I can rewrite this equation substituting everything I know. Negative 6x squared equals this unknown quantity for the vertical rate of change all over negative 1/2. Multiplying both sides by the denominator, I will get positive 3x squared is equal to my dy dt. So as I look at my triangle over here, I can replace this unknown with 3x squared. And they did give me the point that we were looking for. The point is x is negative 1, y is 8. And x is the value I need. So negative 1 squared is 1 times 3 is 3. I'm really looking at a triangle that has a rate of negative 1/2 in the x, 3 in the y, and so my magnitude will be 3 squared plus negative 1/2 squared, or the square root of 9 and 1/4. If I cared to simplify this, 9 and 1/4 is the same as 37 over 4, or square root of 37 all over 2. In some manners would be more simplified, but I'd just probably leave it right there.